Hello everyone, welcome back to Data Engineer Labs. I'm Yogesh and I'm really excited to have you back. Before we start writing more SQL queries, we need to understand a few important concepts that every data engineer works with every day. Databases, schemas, tables, and dot notation. Don't worry, this won't be one of those long theory sessions. We will understand this concept with simple real-world examples and then immediately switch to SQL Server to implement everything ourselves. By end of this episode, you will not only understand how enterprise databases are organized, but you will also master the select statement and write SQL queries like data engineer. Let's get started. Before we dive into SQL Server, let's have a quick look at what we will cover in today's episode. We will start with a quick recap of our last episode. Then we will start with understanding few fundamental concepts such as databases, schemas, tables, and dot notation. These are the concepts which you will come across in almost every SQL project and enterprise databases. Once we have that fundamental ready, we will switch to our SQL Server Management Studio, where we will start with creating our HR schema. We will build tables and we will load sample data into those tables using SQL script. Finally, majority of this episode we will spend in mastering select statement, where we will learn how to retrieve data, how to select specific columns, how to use aliases and benefits of aliases, how to combine data using concat, how to remove duplicates using distinct, and how to limit our results using top. Then we will wrap up this episode with hands-on assignments and data engineering best practices, which you can start applying immediately. Now, before we move ahead, let's quickly recap what we learned in previous episode. We started by understanding what a database table is, and we created our very first table in SQL Server. Next, we inserted sample data into that table, and then we verified that data were loaded successfully. Finally, we wrote our first select statement to retrieve the information from the table. Today, we will build on that knowledge by understanding how databases are organized in the real world. And then we will learn how to retrieve data more effectively using select statement. Remember, everything in today's episode builds on the previous steps. So I recommend following along from the start to finish. Now let's begin by understanding what a database actually is. Now, what is a database? You have seen me creating database from episode 1 and using that database. But do we really understand what a database is? So a database is an organized collection of related data that allows information to be stored, managed, and retrieved efficiently. Now imagine you own a company. Initially, you may store employee data in one Excel file, customers information in another Excel file, and sales records in third one. But as your business grows, maintaining these records or maintaining this data can become difficult, time consuming, and prone to error. So this is where a database comes in. A database solves this problem by providing a centralized location where all company information is stored, organized, and managed efficiently. Think of a database as a digital home for your organization's data. It stores different types of information such as employees, customers, products, orders, projects, and so on in a structured way, making it easy to retrieve, update, and manage whenever needed. Every application you use, such as Amazon, Netflix, LinkedIn, Instagram, or even your banking app, stores and manages its data using databases. As a data engineer, one of your primary responsibilities is to build and maintain system that efficiently stores and processes this data. But if a database stores everything, how does it stay organized? Now that we know what a database is, let's ask another question. Imagine a company has thousands of tables, such as employee, customers, orders, products, finance, and many more. Now, if we keep all these tables together without any organization, finding the right table would quickly become difficult. That's exactly why we use schemas. A schema is a logical grouping of related database objects within a database. It helps organize, secure, and manage data more effectively. Think of a schema as a department in your company, such as HR, finance, and sales. Each department stores its data separately. Therefore, organizing and managing this data becomes easy. For example, HR department can store data such as employee, departments, projects, and so on. Finance department can store data such as payroll, financial records, etc. Sales department can store data such as orders, customer information, etc. We have learned that database stores information and the schema helps organize that information. But where is the actual data stored? The answer is table. A table is an organized collection of related information stored in the form of rows and columns. We have already covered what a table in depth in the last episode, but just to refresh the memory, the table contains data in the form of rows and columns, where each row represents a complete information about one record or one employee, whereas column represents one specific information about each record or each employee. Now that we understand the relationship between these three concepts, a database contains one or more schema such as HR, finance, and each schema contains one or more tables such as employee, departments, projects. The next concept is dot notation, which helps us uniquely identify any table inside a database. Now that we understand what a database, schemas, and tables are, let's quickly see how SQL Server finds or identifies a table. In SQL Server, every database object has an address. Just like every house has a postal address, and instead of using street, city, and country, SQL Server identifies objects using database.schema.table name. Now each part of this name tells SQL Server exactly where to find the table. For example, when we say select star from data engineer labs dot hr dot employees, it tells SQL Server to look into data engineer database. Inside data engineer database, it has to look for HR schema, and inside the HR schema, it has to look for employee table. So this is how SQL Server identifies and finds the correct table specified in the SQL statement. Now this method of defining the table in SQL is called as a dot notation, where we separate each database object using dot. For example, here in the current statement, we have used database as a data engineer labs dot schema name dot table name as employees. Now that we know how to tell SQL Server to look for a table, let's quickly switch to SSMS and implement this. Great. Now I'm inside my SSMS. So I have prepared all the SQL scripts we need for this episode, so that instead of writing everything from scratch every time, we will simply execute the scripts inside the SSMS. All the scripts demonstrated in this episode are available in the GitHub repository. Simply download the repository, open the scripts in SSMS and execute it. GitHub link is available in the description box. This is exactly how many developers and data engineers works in real project. They maintain SQL script in version control and execute them whenever needed. Now there are multiple ways to execute the SQL script in SQL Server Management Studio. In this course, we will use the simplest and most common approach. We will open the SQL script file directly in the SSMS. We will review it and execute it and verify the results. For example, let's go ahead and create a schema. So create the schema. I'm going to open the file from file, open. I'll choose the script which I want to execute. For this instance, we have create schema.sql. I'm going to go ahead and open it. Now you can see the script says use data engineer labs and then create schema. So after every SQL sentence, we will use the keyword go, so that when we execute the script, SQL knows that we need to execute this statement as a single block and then the second statement. So I'll go ahead and execute this complete script. And as you can see, command completed successfully. So now I'll go ahead and create our employee table in HR schema. For that, again, I'm going to open my file, create employees. Okay, so now let's verify this. So this has first command is used, data engineer labs, and then go. So it will execute this command and set up the environment as data engineer labs, and then it will create table HR.employee. So now if you see, we are creating table in the employee schema. That's why we have used HR.employees. Then employee ID, which is an integer and it is a primary key. So primary key in the SQL means this data or this record cannot be duplicate. Like we cannot have employee ID one twice in this table. Also, it will not allow any null values. So as you have previously seen, like we can insert null values for department, salary, and a few other columns when it is nullable, but when it's a primary key, we cannot insert any null values. We will show that also. And then we have first name, which is a text or let's say worker. Again, last name, gender, email, phone, all these are workers. And then we have department ID, which is an integer type, job title, which is a worker of 100, salary, which is a decimal of 10,2, city, which is a worker, country, which is a worker, hire date is date, manager ID is integer, and employment status. Now let's go ahead and execute this script. So now the commands completed successfully. Let's refresh our object explorer first. Now let's verify whether the table is created. So now as you can see, the new table HR.employee is created. This table dbu.employee was the earlier one which we created in the last episode. But this is the new table in the HR schema which is created. Now let's verify this. Let's check the columns. So as you can see now, the columns, the first column employee ID is marked as PK, which is a primary key. It is an integer and it is not null. So table will not allow any null value insertion for this column. Then we have first name, which is a worker, as we mentioned. Last name, again a worker. Gender, again worker. Email, worker of 100. Phone, worker. Department ID is an integer. Job title as a worker. Salary as a decimal. City as a worker. Country as a worker. Hire date as a date. Manager ID is integer. And employment status, which is a worker. So the table is created successfully. Now let's go ahead and insert data. For that, again, I have created the script. So what I will do, I'll go ahead, open the file which loads the employees data, load employee data.sql. Let's go ahead and verify it. So we are going to use, first line is use data engineer labs, which will set up the environment. Then we are doing bulk insert hr.employees. And from this file, which is our data engineer labs employee.csv. Then with some options, first row equals to 2. This tells SQL to ignore the first row and start from the second row. And then the field terminator equal to comma. So basically all the data is separated by comma, and then the row terminator is equal to /n. This means that all the new lines are terminated by /n. Let's go ahead and execute this. Great, command executed successfully. Okay, but it shows 0 rows affected. Don't worry. This is actually something that engineer encounters quite often. Let's troubleshoot it. So CSV file don't always use the same row terminator. We can try changing the row terminator to one of the 3 mentioned in the comment section on the same script. Let's change it to the second one and let's see. Let's go ahead and execute this again. Yeah, now it's executed successfully and we have 100 rows affected. So after changing the row terminator, the data got loaded successfully. You can also try the same method. So while loading the data, if you get 0 rows affected, try changing the row terminator to one of the 3 and it should work fine. Also, we need to create few more tables such as department, employee projects, and projects. I have already provided the script for all these tables. You can simply download it from the GitHub and execute those scripts. The table should be created. Also, I have shared the data as well in the GitHub repository. Please download the same and load it as well using the script. All right. So far, we have understood how the data is organized using database, schema, tables. We have created our HR schema. We have created tables inside the HR schema and we have loaded data inside it. Now it's finally time to start mastering SQL. In this session, we will learn how to retrieve data from database using one of the most important SQL command, select statement. We will try to execute the command based on few of the scenarios or HR questions so that you can understand how and when to use the select statement. So let's start with the first question. Now let's say HR wants to see every piece of information stored about employees, projects, and departments table. So how can we do that? So for doing that, since we need everything, so we can just simply select, we can write select star from. So what star means here is when we execute select star from any table or select star on any table, it will show every row and column available in the table. So for example, here now HR wants to see all the information about employees, projects and departments. So let's execute all of them one by one. So let's also follow the dot notation here. So we'll start with data engineering lab, which is our database, and then HR, which is your schema, and then the table name, which is employees. So we'll follow the dot notation here also. So we'll start with the database and then the schema name and then the table name. Let's go ahead and execute this. Let's see how it goes. So now we can see all the data which is loaded into employee table. So as you can see now, we have 100 records loaded and all the 100 records are available here. Employee ID starts from 1001 to 1100. Okay, you can see the information such as employee ID, first name, last name, gender, email ID, phone number, department ID, job title, salary, city, country, hire date, and so on. So this is how we can retrieve all the information from a particular table. Now let's go ahead and do the same for project and departments. We can simply copy the same because our table resides under the same schema and the database. So data engineering labs .hr.projects. Let's go ahead and execute this. So now we can see all the project details available in the project table. So we have about 20 projects available here. The project IDs, project names, department ID, budget, start date and end date. Similarly, let's go ahead and execute and check all the departments. So we can again write select star from data engineer lab and then dot HR and then dot we have table as departments. So let's go ahead and execute this also. So now we see we have about 8 departments available. Department IDs are 1 to 8 and the department names like engineering, data engineering, human resource, finance, sales, marketing, customer success and IT operations. Now let's move on to the second question. Let's say now HR only needs employee first name, last name and salary. Then how can we get that? So first of all, we have to check where all these informations are available. So when we are talking about employee details, like employee's first name, last name and salary. So all this information is available in the employees table. So what we can do here is we can do select first name first name, comma, last name, and then comma salary from data engineer labs, and then HR schema, and then employees table. So now we got first name, last name, and salary of each employee here. So this is how we select the specific column as per our requirement. So here the HR only needed first name, last name, and salary of each employee. So we just selected first name, last name, and salary of each employee. Now let's move on to the next question. Now let's say HR wants the name to be more user friendly, because here we see the first name without, like, first name without any space and last name without any space. Now HR wants the names to be shown as first name as first space name, last name as a title. So how can we do that? So for that we can use aliases, and we can rename the column on output. So for that we can do select column name which we want to select. Here first name, like this, and then we can use as keyword and rename the column, and then we'll specify inside single quote, we will give it as a first space name. Now since this has two words, like first space name, that's why I have to give it inside single quote. Otherwise we can use it without single quote. We'll show it further. And then let's select the last name, and again we need to rename it as a title. So let's alias it as a title, and then salary. Again let's rename it as an annual salary. So if you see, first name, I have used two words, first space name, which I have given under single quote. Last name, I have used single word, title. Salary, I have used two words, but they are joined by underscore, so I don't need to give it inside single quote. So this is considered as a single word. Now we'll use from data engineer labs, dot schema name, and then dot table name, which is employees. Let's execute this. We'll see. Okay, so now if you see in the output pane, the first name is shown as a first space name, which is Oliver, Arjun, and so on. The last name is changed to title, and the salary is changed to annual salary. So this is how we will change the name of the column on the display using aliases, which is a keyword as in the select statement. Now let's say the HR manager wants to see the full name instead of first name column and the second name, last name column. He or she wants to see the full name. Then how can we do that? So we can use a function called concat here. For that, let's say select, and then we will use concat. We can specify multiple columns or strings which we want to concat here. So let's say we want to concat first as a first name. We will select the first name here, and then the separated by comma, we can select the next value. So for example, let's say we want to separate it by space. So we will mention space, and then comma, we will mention last name. So what it does is concat, it will use first name, it will take the first name, it will add space, and then it will add last name inside that, and then we can rename it as full name, full underscore name, and then comma salary as annual salary from Data Engineer Labs, from Data Engineer Labs .HR schema .employees table. So now if you see, it is giving me the full name. So instead of first name and last name, it has given me full name, which we have mentioned here, first name and then space, one space and then last name, and then salary as a annual salary. So this is how we will concat the different columns which we want to concat, and we can also specify the string which we want to use to concat, or we can also remove this. For example, if I remove this and if I run it, it will show as a first one value like Oliver Smith without space. Okay. Or if we change it to some other value, for example, let's say I want to change it to underscore. So it will give me first name underscore last name, which is Oliver underscore Smith. Right. So this is how we will use concat. Concat is used to combine one or more column, and we can specify the separator which we want to use to combine the column. Execute it. Right. So we'll get Oliver space Smith, Arjun space Smith. Similarly, now let's say HR wants to see how many departments have or they had employees in past. Right. So either they have an active employee or they have an inactive employee, but the department was used. So for that we can select, since we want to only see department, so let's say we can select department ID from Data Engineer Labs and then HR schema and then employee table, employees. Let's go ahead and execute this. Department, oh sorry, spelling is wrong. Department ID, there was a typo. Okay, so now if you see here, we got the department IDs, but if you see, we have the same department ID appearing again and again, right? So this is how we can say we can find all the departments which are available, but this information is not very useful because we have same department ID coming again and again. So how can we remove the duplicates? So for that we can use the keyword distinct. We can use the keyword distinct, and this will remove all the duplicates from the department ID column and it will give me. So let's say now if you execute, we got only our top 8 departments, are all the departments which are available or which had employees or which have active employees in the organization or in the company, right? So we have department ID 1, 2, 3, 4, 5, 6, 7 and 8. So this is how we can remove the duplicates. So now let's say HR team wants to preview only first few employee records, right? Because in the first statement, we saw all the employees data from the employee table, but the HR only wants to verify very few records and say, okay, this is good. So what we can do, or how can we select only few records? For that, we can run select and then we can say top. Now top is a function which will give us only specified rows. So let's say we have given top 5. So now it will give top 5 records only, and then we have to mention what we want. So we want, since we want all the data from the employee, like all the columns from the employee, we will simply mention star, select top 5 star from our employee table, which belongs to Data Engineer Lab database, HR schema and employees table. So let's go ahead and run it. And now you see, we got only 5 records. So for sampling the data, we can always use select top 5 star from table name, which will give us few sample records. So for example, I can give top 10 also. It will give me top 10 records. So if I run select top 10, it will give me 10 records from the table. So this is how we can limit our number of records which we want to see. In this episode, we have covered some of the most important database concepts that every SQL professional should know. Let's do a quick recap of what we have learned today. Today we understood the difference between database, schemas, and tables, and why this hierarchy is used in real world projects. We learned about the dot notation and how SQL Server identifies database objects using the Database.Schema.Table format. We created our own HR schema and built multiple tables on that using SQL script. We imported data inside those tables using bulk insert and loaded from the file. Finally, we started mastering SQL by learning select statement. We practiced selecting all the column using select star, selecting only specified column, and then we renamed the column using aliases. We combined first name and last name using concat, and we retrieved only distinct or unique department ID which are used in the employee table. And then finally we limited our result using tops. These may seem to be very simple query, but these are the few queries which are very frequently used by data engineers in today's world. So for today's hands-on assignment, complete the following SQL task using HR schema. So please go ahead and create the HR schema. You can find all the scripts available in the GitHub repositories. So you can use the same script and create the tables, load the data. And once the data is loaded, you can work on the following questions. You can display all the records from each of the tables you created and then display only the following columns. You can display employee ID, first name, last name, and department ID from the employee table. And then you can create the report in the following ways. You can create the employee ID, you can create a full name of the employee, you can extract the email address, and then also rename the employee full name as employee name. And then you can try to extract only unique department IDs available in the employee table. And then finally create a report using the employee table like employee ID, employee's name, the job title, and the salary of the employee. Before we wrap up today's session, here is some data engineer best practices that I want you to remember. First, avoid using select star in the production environment. While it's great for learning and quick testing, in real projects, we should retrieve only the columns which you need. This improves performance and makes your queries more efficient. Secondly, always use meaningful aliases. A well-named result set is much easier to understand for both you and your teammates. Third, always format your SQL query properly. Clean and readable SQL is easier to debug, review, and maintain over time. Finally, you should practice every query yourself. SQL is hands-on skill, and the more you practice, the more confident you will become. Remember, becoming a great data engineer isn't about memorizing syntax. It's about building good habits from the day one. Keep building, keep experimenting. Thank you.